So lesson 6.6, we are solving exponential and logarithmic equations. We've done bits and pieces of this throughout this chapter already, but we're adding a little bit more in today. Okay, we're getting serious with it, I guess, so to speak. So I've got kind of 3 or 4 different types of problems that we're going to work on. The front of the page, we're focusing on exponential equations. And you'll notice that top section, solving equations using a common base. So as we look at example A, 25 to the 3x equals 125 to the x plus 2. What are my bases? 25 and 125. So the question you need to ponder is, how can I make those bases the same? And this is where that gold paper might come in handy. I think that is my iPad making the noise here. Okay. Thoughts on how I could make 25 and 125 have the same base? They're both what? Okay, divisible by 5, they're both 5 to some power. Look on your gold paper. Where can you find both 25 and 125? They're both in the 5 column, yes? And maybe you didn't need the gold paper for this one. So we're going to start by taking 25 and 125, and we're going to rewrite them. 25 can be rewritten as 5 to the second. So 5 to the second raised to the 3x. 125 can be rewritten as 5 to the third raised to the x plus 2. Okay, so that has got to be your main step here, is get those bases the same. Now, what do you remember about exponent rules? 5 to the second raised to the 3x. How do we put those exponents together? Am I multiplying them or adding them? What? No. Multiplying. You had a 50-50 shot, right? I'll take it. So remember, when you have a power raised to a power, we're going to multiply this. So 5 to the second raised to 3x is 5 to the 6x. What about 5 to the third raised to the x plus 2? What are we going to have to do with that 3? It's going to have to distribute when we multiply it. So 3 times x plus 2 is going to be 3x plus 6. Okay, guys, important part. My bases are the same, yes? Okay, think kind of logically here. If you have 5 to the 6x equals 5 to the 3x plus 6, what has to be true about those powers? If my bases are the same, what? Powers are the same. Think about it. If it says 5 to some power equals 5 to some power, those powers have to be the same since the bases are the same. Okay? So, what we can do here to solve this problem, if your bases are the same, bases have to be the same, drop your bases off and set your powers equal to each other. So we have 6x equals 3x plus 6. Okay? How do we solve? Okay. Basic solving, right? If we want to get our x's together, subtract the 3x over. 6x minus 3x is 3x equals 6. If 3x equals 6, we're going to divide by 3. And 6 divided by 3 is 2. So we have a final answer of 2. If if you put 2 back up into the place for the x's, you will end up with equivalent pieces there. Okay, so in this top section, my job is to make the bases the same, if at all possible. Now, on some of these answers today, we will need to be checking our answers. This particular one is just plugging back into an exponent, so it's going to work. There's not going to be an issue. When we start plugging values back into the logs, which is the back side, we might run into some issues. So we will look at extraneous solutions. Okay, B. 1/2 to the x plus 7 equals 4 to the 3x. Thoughts on how I can make those bases the same? And if you don't like to look at that fraction, start with the 4. What do you know about 4? 4 is 2 to the second, yes? So if I rewrite this 4 as 2 to the second, I'm setting myself up to have a base of 2. Well, what do you know about 1/2? That is, yeah, it's currently 1 over 2 to the first, correct? But how do we get out of the denominator? We're going to give it a negative exponent. So 1 over 2 to the first can be rewritten as 2 to the negative first raised to the x plus 7. Now, power raised to a power, again, we're going to multiply. So I'm going to take this negative 1 and distribute it. 2 to the negative x minus 7. On the right, 2 to the second raised to 3x, we're going to multiply. So 2 to the 6x. If my bases are the same, we can drop the bases and set the powers equal to each other. So negative x minus 7 equals 6x. How would you like to solve? Yeah. Basic algebra here, get the x's by themselves. So if it's negative x, let's add the x back over. What is 6x plus x? 7x. And how do I get x by itself if it's 7x? Divide by 7. What is negative 7 divided by 7? Negative 1. And again, kind of a quick visual. Okay, I put the negative 1 in there. I'm not going to have any issues. Again, it's places where you have issues with negatives, which logs will talk about that. Okay, I would skip C and say we got it, but C looks a little different, doesn't it? 0.001 equals 10 to the 6x. Now, my hint is, as a math teacher, I should not be reading that decimal as 0.001. That's not a good example. How should I be reading that 0.001? Not 100th, 1000th, right? Because it's tenths, hundredths, thousandths. So this decimal 1/1000th can also be written as a fraction. So if I take that decimal and write it as a fraction, 1 over 1000, what do you know about 1000? Yeah. Now, your gold paper is not going to help you with this. I didn't put the powers of 10 on your gold paper. But realize if it's a 1 with 3 zeros, that is 10 to the third. Okay, if it's a 1 with 2 zeros, it's 10 to the second. If it's a 1 with 4 zeros, it's 10 to the fourth. Now, almost there to have our bases the same. What do you do with 1 over 10 to the third? Yeah, that can be rewritten as 10 to the negative third. And now we're back at the same place as we were with the other ones, aren't we? If the bases are the same, you can drop the bases, set the powers equal to each other. So negative 3 equals 6x. To solve for x, I'm going to divide by 6. And what'd you guys get for x? Yeah. Negative 3 divided by 6. I would write it as negative 1/2. You could possibly put it as negative 0.5. Okay. Questions on that section? That's probably my favorite one. I like doing those. Make those bases the same, and then you're working the algebra. Now, as you start to look at the next section, what do you notice? Yeah. 3 to the x equals 15. Can I make 3 and 15 the same with that gold paper? No. 3 is just 3 to the first. 15 is 3 times 15, or 15 to the first. But I can't rewrite them using that gold paper. Okay, so this is going to happen sometimes. Now, the directions suggest solve using logs, and we're going to talk about options of how to do that. And then the directions say round to the nearest 10,000th as necessary. Thus, you need the calculators today. There's 2 different ways I could go about this particular problem. However, there's one way I'm going to choose to go because it leads more into the others. But what is an option you guys possibly see? Okay, so is that, did you say, I don't know if you said it, but could we use left, right, middle here and change into log form? Now, on this first example, I totally agree that would work. Okay, and I have nothing against it, it'll get you to the same answer. I'm going to teach slightly different though because I need to be prepared for some of these others where when I get down to C, can I use left, right, middle? No, because I've got 2 exponents, right? So we have to have a plan B there. So I'm going to kind of demonstrate with some of these others. But here you could do log base 3 of 15 equals x, and we can solve that way. However, the other option, when you can't make the bases the same, and especially when we have exponents on both pieces, is to, when it says solve using logs, take the log of both sides of the equation. Which when I say take the log of both sides of the equation, that just means write the word log in front of both sides of the equation. So I can rewrite this as log of 3 to the x equals log of 15. Okay? Now, my job is to solve for x, isn't it? We had a property of logs we learned a couple lessons back. Or maybe it was just 6.5. It was just 6.5, I guess. What about that power? What about that power of x? Where can it go? Remember the power property of logarithms? The power property says you can take an exponent and you can move it out to the front. So log of 3 to the x can be rewritten as x times log of 3 equals log of 15. Okay. How do I solve for x then, do you think? Okay, we divide by log of 3. And here's the deal, guys. Log of 3. We don't know what it is, but log of 3 is a number, correct? Log of 15 is a number. I haven't written the decimals out for them, but they're just numbers. And so if you think about this, If it's x times log of 3, we're trying to solve for x. What's going to undo multiplying by log of 3? And that's going to be dividing by log of 3. If I divide one side by log of 3, we're going to divide the other side by log of 3. Notice log of 3 can cancel with log of 3. And x is going to be whatever log of 15 divided by log of 3 is. And that is a calculator task, right? So, still required to use a calculator. What are you guys coming up with? Okay. 2.4650. Well, if I recall correctly, it's 2.4649 something, right? 7, and that 7 is going to tell the 9 to go up, but when you take a 9 up, that's taking the 49 up, so 49 goes up to 50. Does that sound familiar? Okay. In terms of thinking about a check here, I'm just plugging that into the exponent. It should work. Again, there's no reason it shouldn't. Okay, so that is one way to do that. Now, what Katie suggested earlier, would that have worked also? Would she have gotten the same answer? Yeah, because if you notice at the time, I believe she said she was going to do log of 15 divided by log of 3. So it still works. Different way to get there. Neither is more right than the other. They're both good. And I'm fine if you use the other one as well. It just won't always work, which is why I'm introducing the other one. Now, B. What's different about B? Yeah. We don't have just the number to the base. We have a piece added. So here's what I'm going to say. You don't want to take the log of both sides yet. What do you think we should do first? Let's subtract the 4 over so we can get that base by itself. So if I subtract 4 over, those 4's cancel. 5 to the 6 minus x equals 11. Now, does this look more like the last one? Yeah, this looks more like the last one. 5 and 11, I can't get those bases to be the same. If I can't get the bases to be the same, then we're going to take the log of both sides, right? So log of 5 to the 6 minus x is equal to log of 11. What's our next step? Okay, take that power and move it out front. Now, it's a little different this time, isn't it? Last time it was a nice plain old x. This time, that power that I'm moving out front is a 6 minus x. So first of all, because it's two pieces, I'm going to suggest you put it in parentheses. So it's 6 minus x times log of 5 equals log of 11. Okay. I feel like I'm full of options today because I have 2 different ways we could go to solve this one. And I don't know what I want to suggest. Okay, I'm curious if you guys see anything. And keep in mind on all these problems, log of 5, log of 11, those are just numbers. I could go ahead and write the decimals down now, but then I just have to write those decimals out every time. I'd rather just wait and I'll punch it into the calculator in the end. Any ideas on ways we could solve for x? Because there's 2 different ways we could go from this point. Okay, and that does work. That is one option. If you look at this, guys, it's 6 minus x times log of 5, yes? One option is to take the log of 5 and divide it to the other side. And then we'll have 6 minus x, and we can solve from x for there. Solve for x from there. Okay? Anyone see the other option? Say that again.
Add it to, so do subtract 6 out the x, and then divide by negative. Because then your x will be positive, so you have to divide by.
Depending on the order of how you do that, yes. Are you talking about for the next step after that?
Like you would add the x and subtract the 6.
Okay, I can't add the x while I have this times log 5 out here. I can't add the x the other side. Now, if I divide the log 5 over, then I could add the x, subtract the 6. I could move things around that way. The other option here, guys, and we don't have to do it. You guys aren't seeing it, so I think I'm going to go the other way, is we can take this log 5 and we can distribute it. It doesn't look as interesting to me either. We're going to have to do it down here. I will kind of give you a heads up, though. But you can take this log 5 and you can distribute it to the 6. You can distribute it to the x because it is just a number. Now, I think I'll save that for the bottom two. And we'll divide. So let's divide. It's 6 minus x times log 5. So I'm dividing by log 5. With this in mind, log 5 cancels with log 5. And I have 6 minus x equals, and I'm just going to write it as log 11 divided by log 5. It's some yucky decimal that my calculator will tell me later. How would you like to solve for x from here? Okay, one option is to subtract 6. And then we'll have to do something with the negative, yes? The other option, which like Autumn, I think you would probably do this. You could add the x, and then you can take this log 11 over log 5 and subtract it as a value. Okay? Again, lots of different ways to do this problem. So if I just go with what I think more of you do, keep the x here. It's a positive 6, so I'm going to subtract 6. That's how I'm going to subtract 6. I'm just going to write it as a minus 6. Again, what am I going to do at the end of this problem? Plug it all into the calculator. So at this point, I have negative x equals log of 11 over log of 5 minus 6. What's my last step to solve for x? Okay, make it do the opposite, right? Which you could wait till the end, or if you prefer, if it's a negative x, we could divide by a negative 1, couldn't we? Okay. I suggested you might need a calculator at your desk today, didn't I? I would encourage you to try this, because here's the deal. There are right ways to do this, and there are wrong ways to do this. Easier to find out now than later. I would just kind of plug it into the calculator piece by piece. So like the first, as I look at what I need to do to solve, first thing I see is log 11 divided by log 5. So log 11 in parentheses divided by log 5 in parentheses. Now, I would encourage you at this point to pause and hit equals. Okay? That would be my suggestion. And then after you do that, what's the next piece I need to do? Subtract 6, hit equals. And then the last piece is to divide by negative 1, which dividing by negative 1 is just going to change my sign, isn't it? So here's what I'm going to say at this point. If you have done yours correctly, your answer matches mine. Did you get a matching answer if you tried? Okay, that's what matters. Because as I said, there's right ways and wrong ways to calculate here. If I go nearest 10,000, so 4 decimal places, 4.5101, I believe. Okay. Excuse me. Yeah. If you tried something different along the way and you got the same answer, then you're good to go. Questions on this one? The top part of the notes was definitely more interesting, wasn't it? I definitely like the top part better. I'm with you right there. But they're not always nice numbers, so we have to have our other way, which is to take the log of both sides. Okay, ready to try C? Three to the x plus 1 equals 5 to the x. What are your thoughts on where to start on part C? Okay, take the log of both sides. Can I get 3 and 5 to have the same base? No, it's not happening. So we're going to take the log of both sides. So I'm just going to rewrite that out by putting the word log in front. Log of 3 to the x plus 1 equals log of 5 to the x. Okay, what's the next step? Okay, is that what those figures were moving, Stetson? Okay, power property says take those powers and write them out front. Now with that power of x plus 1, you probably should put it in parentheses. I don't even know why I'm saying probably. You should put it in parentheses, okay? So x plus 1 times log of 3 is equal to x times log of 5. Now, what makes this problem so different about the last problem? Yeah, there's 2 x's, and 1 x is on the right, 1 x is on the left, isn't it? Okay. So, unfortunately, I can't really just divide by log 3 or divide by log 5 or anything like that, like what I tried to do last time. This is one where my best suggestion is to take the log 3, which log 3 is a number value. Take the log 3 and distribute. Okay? So, what do you think log 3 times x is? Log 3 times x. Now, I will say, because I don't want it to become log of 3x, that I'm going to write my x out front. I'm going to write it as x times log 3 plus, what's log 3 times 1? Log of 3 equals 2x times log of 5. My goal is to solve for x. What do I notice? I have x on the left, x on the right. Where do I need those x's to be? Same side, together, yes? How would you like to make that happen? Subtract x log of 3, move it over to the same side as the x log of 5. Good, I like it. So I'm going to subtract x log of 3 from both sides of the equation. On the left, that just leaves me with log of 3. On the right, x log of 5 minus x log of 3 is just that. Okay? Remember, in order, we have a property that when we subtract logs, if they don't have the x's out front, we can write them as a quotient, like log of 5 minus log of 3 is log of 5 divided by 3, but we can't do that with the x's. So I'm going to write this as x log 5 minus x log 3. Okay. Our job is to solve for x, yes? Right now, x is attached to those two logs. As you look at the right side, think GCF. What is in common on that right side? Both terms have an x and a log. Now, both terms have an x. The logs are attached to the two different numbers, aren't they? So they don't have a log in common because they're two different logs, but we're going to factor out a GCF of x, and that will get us where we need to go. So you guys remember how to factor out GCF, yes? Take the GCF, put it out front, and then you write the remaining pieces in the parentheses. So if it's x log 5 and you factor out an x, we're left with log of 5. Minus, if it's x log 3, we factor out an x, we're left with minus log 3. Do you believe me if I say home stretch? One step left. Okay. So this is x times whatever stuff is in the parentheses there, yes? It's x times that value. So if it's x times that, we're going to divide that. And I can do it because it's all one value in parentheses. So I'm dividing by log 5 minus log 3. And so x is going to be whatever I get on the calculator when I do log 3 divided by log 5 minus log 3. Now, like I said earlier, there's right ways and wrong ways to do this on the calculator. And here's what I need to caution you on. That denominator, because it has two pieces being subtracted, if you are someone that you like to put this all in the calculator at once, you're going to need parentheses around that denominator to make it work correctly. Now, you can do this other ways too, because we could use the idea of second ants, where we use the previous answer. You can do that as well. So if I wanted to do this all at once, I can do log of 3 into my parentheses, divided by, now since I have more than one piece in the denominator, I'm going to do parentheses to begin with, log of 5 into that, whoops, gosh darn it, log of 5 into that parenthesis, minus log of 3 into that parenthesis, plus in the parentheses for the denominator. And there's the answer you should be getting if you found a correct way to do it on your calculator. Maybe? Okay. 2.150, we're rounding 7. Yes? Now, here's the other way. If you don't like what we just did, you don't like the parentheses thing, here's what I would say. Find your denominator. So if I do, because log of 5 minus log of 3. There's my denominator, yes? If I want to do log of 3 divided by that value, remember how I've shown you lately? I can do log of 3 in parentheses divided by, and then that's the previous answer that was on my calculator screen, right? So second ants. That's the previous answer. And notice I get the same answer there, don't I? Now, it all comes down to, you have your calculator in front of you, you have to figure out how you like to use it, right? Okay, where are we at time-wise? I'm debating if I could fully get through D and not be rushing. I'm kind of agreeing. I'm not sure I can fully get through it and not be rushing. So here's what I'm going to do. I'm going to stop us as a class for right now. We'll pick up tomorrow. But what I want you guys to try and do, take a few minutes, try and start D. See if you can start D and make some progress on D. And then we can talk about D, and we can talk about the backside tomorrow. Okay? And we'll go from there.